Welcome back. Today we're going to talk a little bit about covalent bonding as well as reviewing some ionic bonding as well. So a molecule is two or more atoms. They can be the same or different elements and they're covalently bonded. And so these have to be non-metals. So molecules have discrete structures. The formulas show each atom that's in that molecule, unlike with ionic compounds, where really and truthfully it's this lattice work of multiples in those ratios. It's also known as an empirical formula. For a molecule, the molecular formula is exactly how many atoms are in that structure. So pentane, for example, C5H12, it has 5 carbons and 12 hydrogens on it. So ions, ionic bonding, to review a little bit, the cation is positive, so like magnesium 2+, ammonium which has a +1 charge, anions are negative, chlorine minus, SO4 2-, polyatomics, right? Ionic bonding is the attraction between oppositely charged ions. Ionic compounds form crystals. The formulas written are empirically the lowest whole number ratio of those atoms. So for example, barium nitrate. You write the formulas for the cation and anion and include the charges. So we have Ba2+ and nitrate NO3-. That's a polyatomic ion that you have to memorize. The charges have to be balanced. So this means that we have a 2+ charge and a negative charge. Those are not balanced. So to balance that, we would use subscripts or use parentheses if you need to, if you have more than one of a polyatomic ion. So for example, here we need 2 of the nitrates to balance that charge. So we have 2 negative charges and 2 positive charges. So we put a parentheses and a 2 below that. You would then get rid of the positive and negative signs and the 2. So the charges, the 2+ and the negative, we get rid of those to write the full formula. So ionic compounds, cation first, then anion. The monoatomic cation takes the name of the element. Monoatomic anion is the root plus ide, so chlorine becomes chloride. So calcium chloride, Ca2+, the chloride, Cl-, but to balance those charges you need 2 of those Cl- so that you have the same number of positives and negative charges, and you get CaCl2 is calcium chloride. So metals with multiple oxidation states. Some metals, mostly transition elements, form more than one cation. What this means is you have to use a Roman numeral when you're naming it that tells you the charge of that. So this is PbCl2. We know the charge on chloride is -1. Since there's 2 of those, that means the charge on lead, Pb, has to be 2+. So 2+ is the cation, and we would call it lead 2, Roman numeral 2, chloride. Compounds of 2 nonmetals are binary molecular compounds. So we're back to the beginning where we talked about molecules and molecular compounds. So to name them, the first element in a formula is named first. It keeps its element name. It gets a prefix if there's a subscript present, if there's more than one. The second element is named second, and it gets the root of the element plus the ide suffix, and it always gets a prefix no matter what, even if there's only one. So the prefixes that you'll need: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Naming these. First one, P2O5. There's more than one, so diphosphorus, and there's 5 oxygens, pentoxide. The next one, there's only 1 carbon, so carbon, we don't have to put mono, carbon dioxide. The next one is carbon and 1 oxygen, so carbon monoxide, because the second one does get a prefix no matter what. Next one has 2 nitrogens, 1 oxygen, dinitrogen monoxide. Dinitrogen monoxide.